I'm Bodie Long.
I'm Alex Petrov.
I'm Andy Waldo.
And this is Repeated to Beat It. We took a lot of very positive things from DP1 and DP2. We found a lot of confidence, congruency, and consistency that really allowed us to keep our project the same throughout this entire process so that it can be the best that it can be. There are 4 customer needs that we originally got from our interviews that molded all of our concept ideas. They were product quality, variability, cost, and replacement parts. And each of our concepts, including our final design, all included these things so that we can satisfy the customers the best we can. There were 3 categories for each of our concepts that they needed to have. It was a sensor that could communicate with the Arduino, a mechanical component that would be powered by an Arduino, and a physics application that could educate the user. And we decided that a light sensor paired with a DC motor and the use of conservation of energy would be the most effective in educating the students that would be using this BRG. The conservation of energy would be the simplest and best use of physics because a ping pong ball is so massless that it really simplifies all of the calculations that the student will need to do.
Thanks, Bodie. So I would like to review our economic analysis from DP1 and DP2. We made some assumptions here to calculate the total cost and revenue. We assumed that our station costs about $30 per item. We also assumed that our total price for the station would be $100 minus 0.1 times number of items sold. And this is the model we got for that. So as you can see, our ideal number of items sold is about 350, which gives us almost $2,000 of profit per year. And we try to sell more than 200 because that's our lower break-even point, and we try not to go over 500 items per year because we start losing money that way. And this is the proposal we submitted based on the analysis I just described. So we evaluated 2 possible models of borrowing money from VTAPs. The first model relies on us receiving $10,000 in the beginning, and then we paid off at the end of 12 quarters as $15,000. So it's a so-called single payment model. As you can see, we get net present value of about $3,000 for the team for us, and also 12% ROE for VTAPs. And the other model is a continuous annuity payment model where we receive $10,000 in the beginning, and then we pay off $1,200 every month, at the end of every quarter to VTAPs. And that also produces positive net value for us of $2,000, but also gives a slightly higher ROE for VTAPs of 28%. So that model is obviously preferable, but based on the logistics and the easiness of a single payment model, we would like to go with that if VTAPs find that acceptable. And I would like also to talk about project management and how it helped us in shaping and subdividing our resources and time throughout the entire project. And I will be using such tools as Gantt chart and design structure matrix to even further outline the whole idea and efficiency of this method. So our project started in the middle of February, and it ends on May 2nd as specified in the project specifications. And as you can see, we clearly outlined all the tasks and we stick to our schedule for the most part, except for the prototyping phase where we started a little later than expected. But besides that, everything else was clearly followed and followed the Gantt chart, and that helped us tremendously in realizing that certain tasks, for example, task B, C, and D, could be completed in parallel. So that saved us time for future development of our project. And we also use design structure matrix for the same purpose to clearly show which tasks could be coupled or could be done in parallel to save us some time and resources in the long run. And this is our final design, and Andy will talk a little more about that.
Thanks, Alex. For our final design, we were able to create a CAD model in Inventor. And the model is composed of 6 individual parts. And these 6 parts have certain functions that I'll outline for you now. So the ball starts and is raced up the tower and is turned into these 3 varying paths. And the first and third will return the ball on this return ramp, and when it is turned into the second path that will allow it to exit the station successfully. And it is shown in more detail, the isometric view here. And speaking of the function of our design, we can speak on the product architecture. And this design outlines the varying functions of the product and the different parts that are associated with those functions. Now, this shows that we can interchange different parts for different functions. And what that allows us to do is create a family of products that, while unique, can perform similar functions. And that will allow us to really branch out and address a larger, wider audience. And that takes us to industrial design. Now, our product we are able to deduce is safe, easy to use and maintain, and it is also a novel idea to the market. There aren't a lot of products like it. And we were able to come to this conclusion by this chart over here, where we are able to rank different criteria, different industrial criteria. We were able to compare them, rank them, and we were able to see that our product, compared to other products out there, is safe, is easy to use and maintain, and is novel. And that takes us to the time worksheet, and Alex will take it from here.
Thank you. So we completed the assembly time worksheet to evaluate how much time and how much money needs to be spent on the assembly of our stations. As you can see, we reached the conclusion that assembly of one station takes up about 100 seconds, and that using the assumption of price of $15 per hour, that takes us to 42 cents per station. And that table on the right outlines the general trend of which items take up how much time. As you can see, the attachment of ramps number 2 takes up the longest time of about 30 seconds per station. And for example, something like setting up the cup only takes about 3 seconds, so that's very efficient. And using that, we were able to complete the entire cost sheet, where we included the total price for the materials purchased. We included the total labor price, possible molding for the mass production of our stations, and we reached the conclusion that the total cost of our product is about $32.22 without overhead, but then we also added about 40% just to be on the safer side, and that brought the entire cost to $33.63, which is not as far from our initial assumption of $30, which we used in all of our economic analysis. So we were able to change numbers a little bit from 30 to 33, and we still reached positive net profit and positive ROI for VTEPs. So that didn't influence our economic analysis a lot.
With more time, Repeat It to Beat It would like to refine economic analysis, add a second DC motor to make it much more functional, and to allow for varying angles and distances to rebound. But other than that, we feel extremely confident and optimistic about the future of Repeat It to Beat It. Thank you.
Thank you.